All right, so a domain are all the x values of a function. So if you'll note, rather than find everything that x can be in a function, we find restrictions instead. So things to note. The only restrictions really you can find in a function is in a square root, because you can never have a negative in a square root, and in a fraction, because you can never have a zero denominator. So, for instance, the first one is a quadratic function. So, can I plug a negative value into x and get an answer? I can. If I plug 0 into x, I'll also get an answer. And if I plug a positive number into x, I'll also get an answer. So everything for x is going to work, which means in number one, the function is going to be all real numbers. So I'm going to write it two ways. I'm going to write it in interval notation, which means from negative infinity to infinity, representing all real numbers, or I can write it in what's called set notation, which means x such that x, which by the way, the domain will always start out this way when it comes to set notation because domain represents x such that x is an element of all real numbers. Now, I'm just writing both notations because your assignments are multiple choice, so in case you see it one way or the other, you'll be familiar with both. Now for number two, if you know g of x equals x minus 6 over 2x plus 5, there is a restriction here because the one thing you can never, ever, ever have in a fraction is a zero denominator. It will leave your function undefined. So because of that, rather than find out all the x values that x can be for the domain, I'm going to find out the one thing that it cannot be. So I'm going to set the denominator equal to 0 and I'm going to solve for x. So once I subtract 5 and divide by 2, I get x equals negative 5 over 2. This will be the one value that x cannot be, because if I plug that value into x, it will give me a 0 denominator on the bottom. So to write it in set notation, I'm starting off with a simpler one first. It will be x such that x cannot equal to negative 5 over 2. And then for interval notation, keep in mind that the one thing that x cannot be is negative 5 over 2. So I'm going to make a time or a number line just to kind of give you a visual of this. So this is the one number it cannot be. So that means I can use the numbers from here to here. What are the numbers from here to here? It's going to be negative infinity to negative 5 over 2, parentheses, because brackets means that you include that number. So we put parentheses, meaning you can go up to, negative 5 over 2, you just can't actually include it. Union, because there's a break in the number line, and then I include the numbers from here to here, which represent, again, parentheses, negative 5 over 2 to infinity. So negative 5 over 2 again is in parentheses because I can go up to it, I just can't actually include that value itself.